Hello, my name is Dmitry, and today we're gonna find out if JavaScript is single-threaded or multi-threaded. By the end of this video, we will be able to fix this issue when some microtask took quite a while, 4 seconds, and blocked our main thread, which caused some visual lag for these 4 seconds. What we should know as JavaScript developers that we got event loop and it runs under main thread. I got this picture from MDN and its visual representation of event loop. What is important for us at the moment is this queue and stack. Let's imagine we want to run setTimeout and we expect to execute our callback after 100 milliseconds. What actually happens is that our timeout will be registered in queue after 100 milliseconds. It's not executed after 100 milliseconds, it's only registered in queue. So when message number 1 will complete its microtasks and call stack will be empty, it will be time to execute message number 2. And it might take quite a while, for example 1 hour, and it means our callback from setTimeout will be executed after 1 hour and 100 milliseconds. You see the problem, right? To overcome this issue, we can use threads. I get this image from Wikipedia. This is visual representation of multi-threaded process. In our case, we don't want to wait for an hour to execute our setTimeout callback. By using threads, we can just pass our data to thread number 2, do heavy lifting here, and while we're doing it, we can execute our setTimeout callback right away, wait for 1 hour, and get data back to main thread and do our data modification, rendering, or whatever we want with it. You may think it looks like promises, like you doing something off main thread and then get data back, but it's not really like that. When we're using promises, we kind of sending something out of main thread, registering it in our event loop. But when times come, we actually getting back to our main thread and do data computation on main thread. So you may ask, can we somehow overcome this in JavaScript? And answer is yes. We have something called web workers, and basically it's small. What I mean by it, it's capable of doing everything that JavaScript can do with some restricted API. For example, you cannot do some DOM modifications. How it works in general, like you sending message to web worker does a thing like summing up your values, modifying your objects, or whatever you like to do with it. And you can pass message back to your main thread, and then you can use it to like render your stuff, your components, change colors, show pop-ups, on whatever you like to do with your JavaScript. Let's get back to our website example. What we have in here. Let's imagine that you and your friends like to do photography and you like to share what you got today with your friends in some private context, in private web application or website. So I did some example website. It posts some image every 3 seconds. We have some beautiful fallen leaves, fallen sakura leaves, and we have animated background. We have a drop zone where we can drop our image and it will be posted in our website right away. But we have some issue with that. When we upload in our image, we want to resize it first. As you know, the source images from high-end photo cameras could be quite large, like 50 megabytes or something like that. And like I didn't want to pay for storing this on my web server. You know what I mean. I want to resize it on the client side before it will be uploaded on my host server. But when I'm uploading my images and when I'm resizing it, I'm doing some JavaScript computations in main thread and I'm blocking a whole site from render, and everybody laugh at me because, like, you know, I'm using JavaScript, I'm blocking thread and everything lags, and you know that web sucks. I should, I guess, do web application or something like that. My Java friend said like, oh, you know, that JavaScript issue. If I use Java for it, I would just offload it from main thread and compute it and resize image somewhere else. But we actually can do it in JavaScript nowadays. And let's check it out, how we can do it. So what we have here, we have some React component, we have some server mock which pushes one image, one message with image every 3 seconds. We have image container which renders those messages with images, and we have file upload component. When you drop your file, it runs a handle upload image function and it resizes it before uploads. Let's check out our resizing logic. We are doing something like create image bitmap from our file. We get our bitmap, then we create in canvas, resizing canvas with same size as our image size, getting 2D context from our canvas, then drawing image to our canvas. And when we got our image on our canvas, we get in image data and using some library to resize image data. Then we put in back together everything on new canvas, which is quite smaller, just 300 pixels, and put in image data on it. Then we're doing canvas to data URL to get base 64 out of our canvas and uploading result. When result uploaded, it will be immediately posted to our website and we will able to see it. Let's check out how it works. Let's reload image and wait for one image and then drop new one. You see we have counter and it's lagged, and then we got new images and you see we're blocking everything, like no fallen leaves anymore, no new images, times not counting, like it's lagging. I don't like it, and I think I know how to overcome this issue. We can use web workers. Web workers, nicely documented and could be used in various cases. I think this one is easiest that I can get with without doing extra complicated stuff. We will use some npm package inside our web worker called resize image data. Not every npm package could be used in web worker, and yes, I could use the other resizing image npm package, but I'll choose this one for tutorial sake. First of all, we should include specific loader to our webpack config. I use here webpack merge to merge configs. You better Google on how to add loaders to your webpack config if you're using create React app or other way to create React app. So first of all, we should create a folder. How do I create a folder? I see. Called worker. Should create an TypeScript file called size with worker.js. We will wrap our folder, we will wrap our worker with the promise. And let's do export const size with worker, and it will be a sync function that returns new promise with resolve and reject. Let's actually create a file called new JavaScript file called size worker.js, and we have to have it with the postfix worker to able to load it with our loader. We will keep it empty, or actually we can use onMessage right away and register something hello from worker. And actually that's it. We got it. We got our worker in place, and we haven't. We will be this file, this JavaScript file, will be executed in some worker thread. And in worker thread, in global context, we have onMessage and we have postMessage. By doing this, onMessage, we will post something right away. So in our promise wrapper, we will import worker from size worker.js, and we will create a new worker. Just like that. And how it works because we're using this specific loader. So on worker, we can post message to it, like, hey, worker. We're not gonna read it, but anyway. And we should register some event handlers for our worker. So worker on what? On message, I guess. We can add something like I'm thinking, should I resolve it right away? Yeah, let's resolve it right away. We have event. Do we have worker event? Work event map worker. No, just event done. And if we have a message from worker, well, then we resolve it. Resolve with this event. We'll do the same for worker on error. Let's create a new handler with event. It will be, oh, not actual event, but the error event, and then reject with this error. And we actually create our worker with zero logic inside it, and we got our wrapper. I'll suppress it with yes ignore. Because I know it works. So let's import our worker somewhere in here. just to be sure that actually works. Let's get back to our website and check, do we have something in console? Nothing. Oh yeah, I'm just returning the message. I should read it. Okay. So I have result from my worker. Console log result. Why? Okay, I got one more result in here. So worker result. And yep, I'm having a message with data in it that says hello from worker. Nice, it already works somehow. Let's move our logic, resizing logic, completely to worker. So we can delete this. So actually, how we pass in messages to the workers? So while we're doing transfer between main thread and worker thread, we use in time something called structured clone. And it already sounds like it's something slow. When you maybe you can remember that you once in a while doing deep clone of some object, and if object quite big, it takes some time. So with workers we have some transferable objects, and we have a bunch of it. We have array buffer, message port, readable stream, blah blah blah, off-screen canvas. And off-screen canvas actually works well for us in this case. So this one will be not cloned but transferred, and you will lost control over it in main thread. Sounds good to me. So what can I do with that? I can pass control over my canvas to off-screen with method called transfer control to off-screen, and I can pass this off-screen to my worker thread, and I will lose control over it in main thread, but I'm fine with that. JavaScript doesn't know about this property yet. It is in experimental, and I do not recommend to use it in production at all, just for tutorial sake. So with that, we can wait for worker and pass bitmap, which is also transferable file, and we will lose control over it in main thread, but I'm fine with that. And off screen, and in here we will actually come off screen, and we have type for off. Okay, just canvas and bitmap, image bitmap. Do we find the types? Not really. Just swap it. Okay, now it's happy. In post message, we should now path off screen and bitmap, and we should specify transferable types in this array. Now we will be able to get those in our worker thread. So how we can get it? So we have event in here, and let's console log out of here. We have data on event. Well, let's check what we got. Let's drop something in here. And yep, we have our off-screen and bitmap on our worker thread. Let's move our main thread logic to our worker thread. And we should import our package to worker. Size image data. For some reason, it's not picking up correct canvas right away, and I should run it from set timeout to await for one tick of event loop. I actually don't know why, and I don't have much information on web, but it works with the set timeout. Let's check if something was changed. We use an x6 slowdown and images from satellite. Let's drop one more image. As you see, we got no lags whatsoever, and one more, still no lags, and even time reduced. Let's actually run profiler, drop one image, and stop profiler. We have this yellow peak, and you see we have in our main thread were not really blocked, but in worker thread we got something that took actually 600 milliseconds, and it was inside our resize worker. So in this example you saw how can we unblock main thread by using worker thread to perform some heavy computation. So let's review what we did. In our application, in upload resized image function, we got a file, we created image bitmap from it, we created the canvas, we passed control to off-screen, we used off-screen and bitmap in our resized worker, we wrapped our worker with promise, we passed off-screen and bitmap, we registered as transferable objects, and in our worker we used this canvas and bitmap to resize our image. And when we successfully resized our image, we put image data back. As we used controlled off-screen, we not really have to post something out of our thread. We awaited for one tick of event loop, and we were able to use just exactly the same canvas we created to get data URL out of it. And we actually saved quite a lot of time for our users and our site not lagging anymore. If you like this video, hit like and subscribe, and I'll see you in the next one. Bye.